Hello everyone, welcome back. Today we will be solving one LeetCode question, number of 1 bits. Write a function that takes the binary representation of an unsigned integer and return the number of 1 bit it has. Note that in some languages such as Java, there is no unsigned integer types. In this case, the input will be given as a signed integer instead. Let's take a look at the example. Here we have the unsigned integer. The goal here is to count how many 1 that appear in this unsigned integer. The answer is 3. Another example, how many 1 that appear in this unsigned integer? The answer is only 1. How do we solve this problem? We know that in some languages there is no unsigned integer, especially in JavaScript. So the input will be given as a signed integer instead. Imagine the input is 11 as a signed integer. So how do we count how many 1 that appear in the unsigned integer? The answer is we have to convert the signed integer to unsigned integer first, or we can just convert it to the string. In JavaScript, there's a method called toString. We can specify the base of 2. So x here will become 1011 as a string. After that, it will be very easy because all we have to do is just count the number 1 that appear in the string. And in JavaScript, we can just split it into the array. So here gonna be 1, next gonna be 0, and next gonna be 1, and the last one is gonna be 1. Here should be comma. And then we loop through this array and count how many 1 that we have. So we will need a variable called count to store the number of 1 that appear in this array. And after that, we can just return back count. Let's code out the solution. First, we will turn x from the signed integer to be unsigned integer and convert it to string with the base of 2. And after that, we will split it to be the array. And here we will get the array. And all we have to do is to count the number 1 that appear in this array. So I will initialize the variable count equal to 0. Then we will loop through the element in this array. Here gonna be element of array, and for each element we check if the element equal to 1. If it is equal to 1, we increase our count. Otherwise we do nothing. And at the end of the loop, we can just return back count. The input here is ends, not x, so we change x to n. Now let's check the result. This is very good, but how can we solve it using bit manipulation? Let me clean up the example here. Imagine we have the input 11, the signed integer. In bit manipulation, we can use the operator ends to see if the last bit is 1. If it is 1, we can increase the count. And then we have to chop off or popping the most right bit and update the value of the bits. Here we will check x and 1. And the implementation under the hood, it will turn x to be 1011. This is effectively the same as x.toString with the base of 2. But when we use the AND operator, it will automatically convert x to be 1011. And all we have to do is to check this number and this number. This will check the last bits of 1011 with the 1 here. So this 1 here with this 1 here. And it will return back 1 if and only if both elements are 1. If it is not, it just returns 0. And when it returns 1, we can increase the count. So increase the count if the response is 1. And after that, we have to pop or chop off the rightmost element because we already checked it. And in bit manipulation, there's an operator called shift right. So we have to shift 1011 by 1 place. So 1011 will equal to 101. And we keep repeating the process until x or the input here have no more bits. Here it's gonna be something like while x is not equal to 0. And after the loop, we can return the count variable. Let's code out the solution. Let me delete everything here. First, we will need to initialize a count variable to 0. And then we check while ends is not equal to 0. If it is not 0, we want to check ends and 1. This will check the rightmost bits with the 1 here. And remember, the AND operator will return 1 if and only if the two elements are 1. So here we're going to store the response, and then we check if res equal to 1. If it is equal to 1, we increment the count. After that, remember, we have to shift the n here by 1 place. So n equal n 1. And at the end of the loop, we can return back the count. Let's check the result. What is the time complexity for our implementation? The time complexity is going to be O of log n. This is because the number of iterations in the while loop is proportional to the number of bits in the input number, which is log in the value of n. And the space is going to be O of 1, because we don't use any extra space at all. Hope you guys enjoyed it. See you next time.